We are supply chain.
We are supply chain.
We are supply chain.
Nosotros somos supply chain.
I am my supply chain group.
I'm MSCG, and we're your supply chain group.
Okay, we can start now. So hello, everyone. Thank you for joining MSCG's webinar on supply chain planning with SAP for the process industry vertical. This is a 60-minute session with about 55 minutes of presentations and demonstrations and 5 minutes of Q&A right at the end. Just a bit of housekeeping. Please be on mute as a courtesy to your fellow participants. And if you have any questions, feel free to post them on chat, and we will get to them at the end. With that, we can move to the agenda. We'll kick off with a brief introduction of the presenters and my supply chain group, that's MSCG. Suraj will provide an overview of the unique requirements and challenges faced by the process industry. And Himanshu and Sandeep will demonstrate how SAP IBP and S4HANA meet these challenges. Matt will cover the latest innovations and roadmap from SAP in this space. And lastly, Suraj will wrap up with some key takeaways. Your presenters today, we have Suraj Matre, Sandeep Monkar, and Himanshu Garg from MSCG. And from SAP, we have Matt Raymond. Suraj and Sandeep are partners at MSCG and have over 20 years of experience, with a significant portion of it in the process vertical. Himanshu leads MSCG's APAC practice and is an IBP and process expert. Matt is a solution specialist in the process vertical at SAP and has industry experience in the chemical space prior to this. About us, MSCG is a supply chain boutique that's been in the business for the last 12 years. We have 160 plus experts across multiple geographies. We have two key practices. One is planning with SAP IBP, S4HANA, and APO, and execution practice with EWM, yard logistics, and transportation management. We help customers maximize their investment through better strategy, roadmap, process optimization, implementation, and support. MSCG has a lot of process industry experience across milk products, pharma, chemical, energy, and many other verticals. With that, I will hand you over to Suraj for the process industry overview. Over to you, Suraj.
Thank you, Samir, and hello, everyone. So I'm Suraj Matre, and today I will be walking you through process industry overview. So when we say process industry, it comprises of different industries such as chemicals, pharma, paint and coatings, beverage, etc. But today, for the demo purpose, I'm going to focus on chemical industry. So what are the key characteristics of this industry? So we have a huge scale, which is more than 5 trillion revenue per year. It's a continuous operation because you cannot shut down the plant. It has to run 24/7. It's usually commodity market with thin margins unless you are in some specialty chemicals. It's a very interconnected, complex supply chain. A lot of cross-country movements happening, which leads to long lead times and logistics issues. There is a lot of this is make to stock production, so storage constraints become very important. And these products are sold, produced, and transported in multiple units such as rails, trucks, tankers, barges. For solids, you have bags and boxes. For liquids, you have drums, ISOs, totes, etc. So today, I'm going to take this example of the chemical complex to highlight some of the challenges. So this is like a plastic unit, and you have the procurement side where you buy ethane, propane, naphtha, catalyst, additives, etc. That goes into those are so the raw material is cracked to get intermediates such as ethylene, propylene. They are then polymerized to get resins for like polyethylene, polypropylene, PVC, etc. Those are usually sold to other manufacturers, which then convert them to this end products, which are sold to the end customers. So what are typical challenges we see here? From procurement side, you can have allocations where if you are limited on raw material supply, you want to allocate it to high margin products. You can have long lead times. There are contracts and they stipulate things such as what's the minimum that you have to buy, what's the maximum you can buy, the prices, etc. When we come to the production side, you have all the distribution challenges. You have to do minimum utilization because you can't shut down the plant. You do the cost optimization. So you get into fair shares, priorities, etc. A lot of companies do swaps and exchanges with other companies. There are usually co-products that makes planning difficult. The BOMs and production rates are time-phased because the catalyst usually degenerates. You need to do batch visibility and traceability. You need to optimize your transition. So there are product wheels, campaigns, all those transition matrices, all those things going on. You need to ramp up and ramp down production depending on the demand. You need to merge orders. There is again, tank planning because of storage constraints. Subcontracting is important because a lot of these products are packaged by subcontractors. Load building, where you decide how am I going to load my rail cars and trucks. You can have same product being made on alternate reactors. When we come to the customer side, you have a lot of these product sales and customer hierarchies. You can sell the same product as reclass and rebrands. You have price formulas and markers. You have rebates and discounts for customers. The allocations are important because many times the demand is higher than supply. So how do you allocate the supply to customers? A lot of these products can have seasonality of the demand. So summer demand is higher than winter demand. You need reports on margins, netbacks. You need reports on cost to serve or cost of goods sold, all those things. Demo, Himanshu and Sandeep are going to do demo, but before that, I'm going to set the stage. So we have a simple network here where there are a couple of plants. We crack the raw material to get ethylene and catalyst, additives, all these things. We have these 3 reactors in this plant, a couple of them high density polyethylene and linear low density polyethylene, which polymerizes ethylene. Once you have the resin, the product is usually sold to, it can be sold to customer directly in the rails, or it can go to the terminal where we transload it to the truck and sell it to customers. It can also go to the subcontractors where they are packaged into bags or boxes and then they are sold to the customer. Now in the demo, we have a lot more products than what I have here, but I just highlighted a couple of them so that you can follow it through the demo. So just remember 21, 22. And the problem we are going to solve in the demo is our demand is higher than the supply. So that means I have to allocate whatever supply I have to customers. I also need to produce it more efficiently, or sometimes I have to rebuild. So all that minimizing the transition to maximize my production capacity becomes important. So one last slide before we go to the demo. This is the process we are going to follow. As you know, SAP has this IBP, which are these different modules used for planning. And then we have S/4HANA used for execution. So we are going to use the demand module, the response and supply module, inventory module, and S/4HANA. And we picked this particular setup because it addresses most of the challenges we have, covers most of the challenges we have discussed. But each customer can have different requirements, so they can pick and choose some of these modules. SAP is very flexible the way you can do planning. Also, we are going to do this demo in 2005, but 2008, which is coming out next week, has a lot more added capabilities from the integration point of view. So coming back to demo, we have demand planning. We are going to get a consensus forecast at the SKU customer level. The reason we don't have, notice that we don't have plant here. So there are a couple of things because we don't want the sales guys to know which plant to source from. Also, it takes care of a lot of realignment issues. Then we move on to the tactical planning. Here we do the time series optimizer solver. You can do rough cut planning. You can do all the simulations, everything. It's usually done in monthly bucket, 12 to 18 month horizon, and usually run once or twice a month. The other thing is we also model the customer in here because that's how we get this constraint forecast, and now also we also assign the plan to it. This is then sent to the order series, where now we are in a operational window, which is tactical operational window, which is we can do daily, weekly buckets, usually shorter horizon, 4 to 6 months. Also here, you have the option to either have customers or not have customers. In the demo, we are modeling customers here because we wanted to do forecast consumption at customer level. If that's not your requirement, you can just model this at SKU plant level and you will get much better performance from the solvers. So here we generate these planned orders, purchase requisitions, stock transfer orders, send it to S4. You can do deployment orders, which is short-term distribution, and allocations and forecast. And then once in S4, we do ATP allocations and schedule the orders to minimize the transitions. And all these orders and other transaction data comes back to order series. So we have some horizons where we actually fix these scheduled orders, then the horizon where we run the scheduling, and horizon where the order series solver runs. But it's much deeper discussion, so I'm not going to get into that right now. The reason being that these horizons can be different for different businesses. For example, for polymers, your orders can be more than a week long, and the product will can be more than 3 months long. So those horizons can be, it's obviously going to be different than anybody else, the other business where your orders are only less than 1 day long. So you can contact us later if you want to discuss those things. Also, I have here this load building. This is in the roadmap for SAP, and it will be in the transportation management module. That's why I have it in gray. So if you have any questions on this process, again, we can talk after the presentation, or you can contact us later. And with this, I'm going to hand it over to Himanshu.
Thanks, Suraj. Please, Himanshu. Yeah. Hi, everyone. I'm Himanshu Garg. Right. I'll be walking everybody through the IVP processes that we have modeled for this demonstration. So starting from demand planning, going into tactical planning in time series optimizer in IVP. And the output from time series optimizer will take it to the order series for operational planning window, and we'll integrate the results from order series back to S4HANA for scheduling and allocation check. Right. So inventory optimization is another module that we are using, and we are getting the safety stock number into time series as well as into order series. But we'll not delve too much deep into inventory optimization in this demonstration. So within demand planning, I'm going to show you the statistical forecast and consensus planning. Okay. So for this demo, we are going to use the web user interface for IBP as well as the Excel interface for IBP. So let's start with the web user interface. So here we have a dashboard where we have put together some analytics from demand planning and supply planning. So the first analytics that you see here is the forecasting analysis analytics. Here what we see is the actual quantity adjusted number, the historical sales for all the products in the model, and also the stat forecast quantity for the future horizon, and the sales forecast quantity, just for comparison. All right. Then the other thing that we see here is the consensus plan that we have created for the process industry. And what we see here is the consensus demand plan. We also see the sales forecast revenue in the orange line, and the green line is the annual operating plan. And all these numbers are in revenue terms, not the actual quantities. Right. So I'll show you the same information in Excel. Okay. So this is the Excel view in IBP, and this is the consensus plan planning book that we have developed in Excel. And as Suraj mentioned in the overview, that we are doing our demand planning at the product and customer level. So here is the product on the left hand side and the customer. For this product 21, we have multiple customers for which we have forecast and sales forecast, marketing forecast, and operating plan, and finally the consensus demand plan. So this consensus demand plan that you see here is in tons, and the product itself is managed in kilograms, right, as the base unit, but we can see data in tons or any other mass unit that is associated with the product in IVP. Now this consensus demand plan quantity is the figure that is passed on to supply planning for S&OP purposes in time series optimizer. Right. So going back to the presentation, now we'll talk about the tactical planning in IVP using time series optimizer, right? So in time series optimizer, what we have is we have modeled all the priorities for different products, different customers. We have modeled the inventory holding cost and the non-delivery cost and other various costs, for example, the production cost, all other penalty costs, to come up with a feasible supply plan, right? And we are also using the fair share within time series optimizer, which helps us to allocate the constrained supply to respective customer demands. Right. So what I'm going to talk about is the consensus demand versus fulfilled demand, the capacity and its impact of pre-building. In case we have a capacity shortage, system tries to pre-build if it can to meet the peaks in the demand pattern. Then we will also talk about the time phase bomb and the batch visibility within IVP. So I'll take you back to the dashboard first. So in the dashboard here we have an analytics which talks about what is the consensus demand that we received from demand planning and what is the constrained supply that the IVP time series optimizer has calculated against this forecast. So in the first month you can see that we are already so far down in the July that our constrained supply is very little as compared to the forecast, because we don't have enough time to procure materials, we don't have enough capacity available. Similarly, going into August, we are a little better off as compared to July, but still we have a lot of shortages. Then in September, we are very close to our demand, and so on and so forth. So here you can compare. And the other figure that we can compare it with is the sales forecast quantity, how we are tracking along the sales forecast. So I'll show you the same data set on Excel side to give you a better understanding how we can see the same data set at a detail level in Excel. We can see the same thing in analytics as well, but on the dashboard, we can apply filters. Now this is a planning view where we have the customer demand at the product and customer level. So this demand is transferred from demand planning, and the output of the supply planning is visible in this key figure, total customer demand delivered. So this is the constraint supply that optimizer has generated. And here you can see that there are certain weeks where optimizer is simply not able to meet the demand in this case. Then for another customer, you can see that it is not able to meet demands in the initial weeks, but it to meet partially, the forecast that we have received from the own planning. but wherever it cannot, it is just shorting the demand. But on the other hand, this is the other product which can be manufactured at more than one resource. So you will see that wherever it is not able to secure supply on one resource, it is moving on to another resource, and it is trying to fulfill as much demand as it can. So the way we have modeled is that item 22 has more priority as compared to item 21, and as a result, you will see there are less shortages for item 22 as compared to item 21. So the system is trying to fulfill the demand for item 22 before it attempts to fulfill completely for 21. Okay. Now this is the view at the product and customer level. Now this demand is transmitted down the supply chain upstream to the DC and further to the factory, and that information is visible on this planning view, which is at the product and location level. So different customers for this product 21 send their demand to the DC 3500. So 3500 is supplying to all the customers, and we can see here the dependent customer demand for respective customers. So we are getting the demands in respective buckets. And if I scroll down, we can also see the supplies that are coming in from the factory, the stock on hand, and other supplies that are coming in from the factory as purchase equation or STRs. Now going back to the factory, whatever STRs we see at the DC, we see them as dependent location demand at the factory level. You can see here. And these demands are being met by the production. So what we see here is the production order that exists in the next week. System is able to look at that production order, as well as it can plan additional planned production in IBP. And this planned production may not always match up with the dependent demand, because in case, as I said earlier, where we have capacity shortages, for example in week 39 it is not making any production, but it is pre-building stuff. As you can see in week 35 we have a projected stock which is nothing else but pre-build, right? So it is trying to build stock ahead of time so that it can meet demand in later weeks. Similarly here you can see the pre-building happening. Okay. So now let's take a look at the capacity situation. Again, going back to the dashboard. Here we have a couple of analytics which talk about the key resources that we have in this model. These are the two reactors that we have modeled at location 2000. And you can see here the reactor 1 is almost 100% loaded every week except couple of weeks, right? However, the reactor 2 is 100% loaded in initial buckets, but then it is a little relaxed. And the reason for that is that the demand in the first couple of months is very high as compared to remaining months, being the seasonal products that we have in the model. And on the right hand side, you see the same capacity situation, but divided by individual products which are running on those reactors. So the color of these bars represent different products. So the red bar is for product 22, the green bar is for product 21, and the violet bar is for product 27. These are the three products that we are using in this model at the location 2000. And the other thing that you can notice is that the green bar, which is product 21, goes over to another reactor, reactor 2, whenever the capacity is not enough on reactor 1, because that's the preferred resource, but it can always switch over to the alternate resource in IBP when the capacity is not enough on the preferred resource. And same goes for this product 27. Okay. Now, what I would like to show you is the time-phased BOM component. So in IBP, we can model time-phased BOMs for tactical planning. So we can choose to have different component coefficients of the BOM component as a function of time in IVP. And when the system plans production, it will create dependent demand for the components based on the component coefficient of that particular bucket, not using the regular BOM. So this is a very helpful feature for chemical industries, and we can do it in S&OP process. We can do simulations. We can model different simulations with see the impact, and then adopt whatever changes we like into active version. So that's one thing. Then the other thing that I wanted to talk about is the batch visibility in IVP. So in IVP, we can bring in the individual batches of the stock that is available at manufacturing location or the DC. And we can see that batch stock within IVP with the batch characteristics as well. So we can map each and every characteristics for the batch from your ERP system into IVP. Okay. So one key thing that I would like to touch upon is that the tactical planning that we are doing in time series, that planning horizon could be 2 years, 2 to 3 years, or much longer, depending on the customer's requirement. But the result that we get from tactical planning is a rough cut capacity plan, right? And this plan has to be planned in a much more granular fashion using the order series. And that's the handover that we will do now. So going back to the presentation again. So the next step in the process is to pass on the constraint plan that we have generated in the tactical planning to order series for a more closer look in a short-term window. So within order series, what we're going to look at is how we transfer the plan from time series to order series, the result of the constraint forecast run, the production plan with capacity constraints, and the deployment plan, as well as the order details for planned orders or production orders in IVP, and the allocation that we generate within IVP, which we're going to hand over to S/4HANA. Okay, so going back to the BOI. So I'm going to use web-based planning for order series, just for simplicity. So in order series, we have this first view, which is the forecast constraint view. Here what we see is the constraint forecast that we received from time series. So the result of the time series tactical planning is transferred to order series as constraint forecast, and we do an optimizer run within order series to generate the constraint forecast, right? So the difference between order series and time series here really is that order series is able to create a plan at in daily buckets, right? And the tactical planning that we did was weekly buckets or monthly buckets, depending on how we choose to do it. So we get the constraint forecast, and in my example, the constraint forecast is always matching with the forecast that we received from time series. There is no difference. But please keep in mind that order series in this example is supposed to run every day, and whatever changes that you get in supply situation or a demand, if you get a higher sales order, then those situations will make this plan a little bit variable as compared to time series. But largely it should keep tallying with the time series planning. Okay, so now the other view that I wanted to show was the deployment view. In the deployment view, we will see more colors of the plan. So in the previous view, we only had the forecast and constraint forecast. Here, what we see is all the demand and supply elements across the supply chain. So if we just focus on this product 21, this is the factory specific data that you see here. What we see here is the distribution demand from deployment, right? So, and distribution demand, which is planned. So the total distribution demand is about 6.6 million at the factory. And what we see here is the receipt side of things. So we have initial stock of 150,000 and production planned for 4.2 million. Now I'll show you the order information. So 4.2 million, how it is all made up of, how many planned orders it is made up of. We can see all those details here. So basically we have 3 planned orders. So 2 of these planned orders, starting with this T series, these are created within IBP after the planning run. And the second planned order that we see here is 12321. This planned order has come from S4HANA, because in S4HANA, if we fix a planned order, that planned order remains as fixed for planning in IBP. If you focus on these 2 columns. So fixed for planning, so that means IBP cannot delete or change this planned order. IBP can always create additional planned orders or adjust existing IBP planned orders within IBP. So any planned order that is created within IBP is not fixed for planning. It is changeable. Okay. Now, if we wanted to see the pegging information, we could simply click here and it will take us to pegging. But I'll just move on to the next phase, which is the allocation. So once we have completed the order-based planning, we copy the constraint forecast into allocation. As you can see here, we have copied the constraint forecast from order series into allocation, and we see the sales order information, how much sales order is coming through, how much it is consuming, and all that in this view. And then in our scenario, we are passing the allocation back to S4HANA, and we are doing the allocation check and ATP check within S4HANA, not in IBP. The other thing that I would like to talk about is this intelligent visibility, which is the latest feature in SAP IBP. So this is a visual tool available in the web UI where all your network is mapped out on a global map. Along with that, we can also see the cluster of locations and the alerts that we have defined in the system here highlighted in red. So if I just click on this red box, it will show me all the locations which are included in this cluster, and I get this number 3 against 3500. So this is the distribution center against which we have a couple of alerts. So these are the alerts that we see. Sales orders are not being delivered on time. So that's the alert. And you can go into further details on the same screen, and it will show you the details of the sales order. And if you wanted to see some gating factors, it can show you that as well. Now with that, I conclude my demonstration within IBP. So the result of this whole process is the allocation that we pass over to S4HANA, as well as the planned orders and deployment STRs that we pass over to S4HANA. So that I hand it over to Sandeep. Sandeep, please go ahead. I'll stop sharing.
Okay, sorry, I was on mute. Can everybody see my screen?
Yes.
Okay, perfect. So thanks, Himanshu. So what I will do is, I'll take it over from here. We'll look at the way allocations are, transferred to S4HANA. Then we'll look at few of the, scheduling challenges that can be overcome within S4HANA PPDS, and we'll just go through the system. We'll talk about few challenges and some of the tools that are available for the planner or scheduler to overcome those challenges. So I'll start off with, from an allocation perspective, what we have is, those allocations that are from IBP, we can actually simply upload them to S4HANA using a simple download upload, or if there is some automation that is needed, we can work that out too. But for the ease of the process, what we have done is we have simply taken those allocations, the numbers. If we were tracking the numbers that Himanshu was and the products that Himanshu demonstrated, I simply downloaded it from IBP and we just uploaded it to S4HANA. And from this point onwards, depending on at what level we want to consume the allocations, it does it based on the incoming orders. But essentially, it's all web-based, UI for allocation, maintaining all the attributes and everything else that we would typically in the older systems we were actually configuring. Right now, it's all in Fiori. So once the allocations are there, incoming orders start consuming those allocations. And then what we have is within Fiori, if we start getting into the scheduling part of it, what you may see is we've got two tiles for scheduling board. One is the Fiori based app that SAP delivers, and what we use typically is, this is something that we do at most of our customers. The reason being some of the graphical features and advanced features like optimization, those capabilities are not yet available within the standard app. So what we do is we basically, using NetWeaver business client, we just call the standard transaction. And then from that point onwards, sorry, it's just seamless from a scheduler's perspective on using the DS board and the features of the DS board. So that's exactly what I have done here is basically it just opens a new screen and just tells you to enter your DS board, profile, and it should end up in this screen the way we see in standard DS board. So what we have here is, for easily tracking, what I have done is we have just color coded some of these the orders that we have. And if I just quickly flip back to the challenges that we have from a process industry perspective, we talk about, Suraj spoke about continuous production, right? So we don't start like discrete. Then we have batch sizes, which are quite important depending on how long your runs may be, from a few days to maybe even week or a couple of weeks, depending on how long your campaigns are. Then as part of the response, when we get these daily orders, we don't run those orders in daily format. We have to merge those orders. We might create campaigns within PPDS. And of course, the classic drag and drop features, which helps the planner to fine tune or refine the schedule based on execution within the execution windows, based on whatever issues or challenges that might come in. So as we spoke about, I can from a merge perspective, we've got some things that we can merge and build a campaign and have a longer run and just see the impact of that within our the stock chart, or we may have a graphical stock chart, or we may have a tabular stock chart. We can use even drag and drops if we, depending on if I want to move it from one reactor to other, so we can do that. So all these simple kind of tools, but which make the plan more effective and gives better visibility and tracking from a within the scheduling window. So I can even add, for now we've just added a couple of charts. We can add more charts if we want. We can add the additional two charts that I typically use. One is the product chart, which even tells us the demand supply snapshot within the same DS board based on the scheduling changes, whether am I meeting the demands, and that those demands may be different for an STO, for a cross factory transfers, as well as the sales order demand. So we can prioritize demands differently, color code them differently. then what we have is, again, what we are not getting today is into campaign optimization, which is there. We can use optimizer for setup optimization, which has been there for a long time. We can use that setup optimization. So based on the production wheel that comes in from IBP, we can, build similar kind of production wheel within S4 HANA. And, depending on how we play with the setup metrics, the results are pretty good and close to the way a typical chemical plant would actually run. So other than that, I think then we talked about drag and drop. So just if I sum up a few things that we just looked at from a DS board perspective, we looked at the integration of allocation. There is some automation that can be done within, from an allocation standpoint. We looked at scheduling of orders. We can merge orders, create big campaigns, drag them to alternate resources. Ramp up, ramp down is something that can be done if we want to, if we are in that kind of situation, we can actually get to the ramp down, ramp up. We can actually go and, stretch and shrink the orders. So I can actually. So I can actually, depending on how up and down we've got some range over here, I can actually, shrink or stretch the orders. So just this helps typically during ramp up, ramp down kind of situations. So once, all these tools are standard out of the box, and then once the execution results come in, we can actually, transfer those results back to IBP and have an end-to-end seamless kind of plan. We started with the time series, demand planning, constraint forecast. We got into order series, and then we looked at the whole scheduling, sequencing within PPDS. So with that, what I will do is I'll hand it over to Matt, who can talk more about some of the innovations and the roadmap from a product perspective. Over to you, Matt. Yeah.
Thank you, Sandeep. You can go ahead to the next slide. Okay, thank you. I'm Matt Ryman with SAP, the Chemical Industry Business Unit. I only have 10 minutes. I'm just going to jump right into this. So to level set, here's a view of our portfolio of products. I think it's important to note from a business process level how we are connecting strategic and execution level processes. And it starts with the tactical planning processes where we're focusing on a longer planning horizon, could be 1 to 3 years. And through these tactical processes, we work through our S&OP cycle, right? We achieve our consensus demand plan and rough cut capacity plan. From here, we move into the operational planning processes where we're working in a shorter planning horizon. So from here, we're able to build our master production schedule, deployment planning, then ultimately into execution level processes. Our technology stretches end to end with IBP covering these tactical, midterm, and short-term operational capabilities, S/4HANA for execution, and even expanding into the network with Ariba. Next slide, please. So just a quick disclaimer, any discussion on future developments are subject to change, and this information is not a commitment, promise, or legal obligation to deliver any material code or functionality. Other housekeeping item, in case you're not familiar with the nomenclature of our product releases, so for example, 2005, the first 2 digits correspond with the year 2020, or 20, it's 2020. The second 2 digits correspond with the month. So 2005 was our May release, 2008 is our August release. So certainly this only is going to touch some of our highlights. We're delivering improved functionality in all of our modules. I do encourage you to participate in our What's New session that development does quarterly, where we pack in a lot of content. For us today, I'm just highlighting some of the areas in our operational planning space As I said earlier, think shorter term planning and operational planning is also synonymous with order-based planning. So some of our recent highlights: deployment optimization was introduced as a new planning run in 2005. So deployment generates a short-term distribution plan to distribute available supply, and now we're able to optimize this considering network cost. Also in 2005, we have some improved web-based planning capabilities. As you saw in the demo, you can show order information in the web-based planning app, light touch, easy to use, and provide a level of detail to see the results of the planning run. In our upcoming release, in the deployment space, we will deliver fair share distribution, and so fair share for demands lets you partially fulfill independent demands in case of supply shortage, and fair share for inventory lets you evenly distribute inventory. Also, in our upcoming 2008 release, we will deliver an integration pattern with order-based planning and embedded PPDS on S/4HANA 2020. So this will be available after the upcoming S/4HANA release, and I will talk about this topic more on the next slide. As we wrap up the year, we will have transportation resources to allow us to define the available transportation capacity per transportation lane and mode of transport. And then as we look into 2021 in our outlook, some other topics that are relevant for chemicals and the process industry: co-products, recursive bombs, infinite heuristics, subcontracting, real-time integration. And we look beyond that into 2022, we'll continue to enhance our capabilities in deployment planning. In this case, the load consolidation will be based on the output of deployment planning. It will determine stock transfers to be consolidated and then make a call to SAP TM to generate the load, and then also 2022 outlook, capacity leveling. So again, this is part of our order-based planning or operational planning. It's not all, it is certainly not everything, and again, it's subject to change. Sandeep, next slide, please. Okay, so moving forward on this topic of synchronized planning. So fundamentally, as the name suggests, it's about synchronizing our network plan and our plant-centric plans. And so this first integration scenario will be introduced with IBP 2008. And again, as I mentioned, with the 2020 S/4HANA release. So this is the first delivery on this topic, and it will continue to expand. The first integration scenario will be called Detailed Scheduling Delegated. So in this case, IBP order-based planning owns the production process while embedded PPDS does scheduling and sequencing. There's really two important components to this. So there's now a handover from IBP to detailed planning in what is being called the detailed planning and scheduling horizon. And then secondly is the ownership piece. We can distinguish between IBP orders and detailed orders scheduled by embedded PPDS. As I mentioned, this is the first step of this topic, and we'll continue to improve functionality and offer additional integration modes in future releases. And there will be release documentation available, so we'll keep an eye out for that in the coming months. Sandeep, next slide, please. Okay, so why is this important? So we're really bringing together important pieces of this end-to-end process, and this includes our network view, deployment processes, production planning, logistics capabilities, and the ability to monitor in the control tower. And we look at our current capabilities, we have a lot of flexibility to do simulations and a solution that's much less rigid than APO. This topic expands our ability to provide quick responses in the short-term planning process. And if you recall, in the beginning of the session, I mentioned the various planning horizons, right? There's different dimensions in these supply chain processes. They require different capabilities. So the ability to bring these capabilities together, to synchronize them, and to continue to drive integration is really how we're creating total value and a key part of this innovation topic. Next slide, please. Okay, real quickly, you saw a bit of embedded PPDS and S/4HANA. This is the manufacturing roadmap, and I wanted to highlight the PPDS sections. They're highlighted. So in that first section that's highlighted, the enable time bucket finite MRP. Behind this, we are delivering a production planning optimizer also known as the PP solver. So this is going to provide capabilities for more complex environments like multi-level constraints. So I can't go into detail today, but I just wanted to make you aware that we do have an important delivery coming out in the upcoming S4HANA release for PPDS, and certainly happy to continue that discussion if you're interested. And then the second bullet there is the synchronized planning from the perspective of PPDS. Okay, next slide, please. So that my penultimate slide, I wanted to highlight the concept of the control tower. So you saw a bit in the demo. I think the value proposition is becoming clearer in the industry. This concept is about this holistic view where you can define alerts and manage by exception and then drill down into these exceptions to resolve. So to put some color around one of the use cases, consider inventory visibility, particularly in the case if there's any sort of supply chain disruption. One of the first tasks at hand, understanding inventory in the network, what's on hand, what's in transit, what's projected, right? And then being able to navigate to warehouse management, TM, or production planning, detailed scheduling, or IBP to consolidate this global visibility, delivering a lot of speed in that assessment. So some of these capabilities exist and will continue to improve functionality. But again, just wanted to put some color around a control tower and to demonstrate the value. And that brings me to my last slide, Sandeep. Just for your information, we do have a new roadmap tool. There's a link here in the deck, and I hope you take advantage of it. It's quite nice because you have this kind of free field filtering that you can filter by industry or process or even products. So hope you can take advantage of that to have a further look. Again, just a glimpse into some of the innovation highlights, and happy to talk more. Feel free to reach out. So Sandeep, I think that's it for me.
Thanks, Matt. With that, what I'll do is I'll hand over back to
Sandeep. We can continue
Yep.
sharing. So thank you, Matt. Thank you for that insight. So we saw the demo and some of the SAP innovations. So I just want to tie it back to the challenges that we talked about before. We looked at the distribution plans. We looked at the cost optimization. We looked at time-phased bombs and production rates. We saw we can see the batches in IBP. We looked at some of the scheduling part of it. We did merge orders, ramp up and ramp down of orders, how to drag and drop to alternate reactors. We looked at that. We looked at product sales and customer hierarchies. We looked at allocations. Unfortunately, some of the ones that are gray, we don't have enough time because of the time constraint, but you guys can contact us later and we can go through that. Also the green thumbs up, just wanted to say those are the standard available features. Then there are the SAP roadmap features, and the MSCG solutions are the ones which where we have done some workarounds or some other things. You can go to next slide. So the final takeaways. So what we saw today was for process industry, the supply chain planning is a complex thing, but we can address these challenges. So it's SAP IBP and S4HANA is now capable to handle these challenges. We also saw the SAP tools modules are flexible. You can pick and choose those modules based on your requirements, and SAP is planning more and more improved functionalities with each release, and it's going to just get better from here. So with this, we can go to Q&A.
Yeah, thank you, Suraj. So I think I looked at the Q&A the chat while everyone was talking. It looks like most of the questions have been addressed. I think there's one outstanding question from Saurabh, but I think it seems to be a more detailed question which merits a separate discussion, and I don't want to lose the rest of the audience in that discussion. So maybe we can address it. Are there any other open questions that people haven't asked yet? You can you may have to unmute yourself or just put on chat. We can look at it.
Yeah, this is Sammy. I just wanted to ask, how easy is it from getting from a, a material customer level and a time series down to the plant level. Is that normally just using disaggregation and demand, or is there some not custom function, or is there some additional functionality to easily assign a plant to that level, to get down to the plant level when you get into, the response and supply area?